Right. Okay. So four exclamation point, and then what does that bar mean? Yeah, it's like a long dividing kind of thing. Divides into, right? So 4 with that exclamation. What's the 4 with the exclamation point? Have we talked about that?
Factorial.
Yeah. Do you know it?
Yeah, it's everything after the 4 multiplied.
Yeah, it means 4. No. Sorry, I was joking around. Yeah, you're totally right. It's called 4 factorial. It means 4 times 3 times 2 times 1. Yeah. So this going to have a bunch of these. Yeah, so it's called 4. Oh, yeah, I said it right here. This right here. Note that 5 factorial is equal to that. Yeah, that's right. Yeah, so it's called factorial. I'll write the word out here. Factors are things multiplied by each other. So that's why they're using that name. It's things multiplied. So anyway, so basically they're asking, does 4 times 3 times 2 times 1 go into 30? Which is, I don't know, what is that? 12 times 2, 24. Does 24 go evenly into 30? Well, no. Goes in once with a remainder, huh? Doesn't go in evenly. So that's false. It's a false statement. All right, how about part B? So that's part A. How about part B? I'll do B over here. Does 80 go into 25 factorial? Yeah, you have your calculators? Want to try it? Can you do 20? You guys, can you do 25? There's usually a factorial button on your calculator. I don't know if you can find it. You don't have to find it. But if you can find it, it would be convenient. Hit 25 factorial. You know what you're going to get? Something huge. Something crazy huge. You're going to get something really, 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 really big. 25 times 24 times 23 all the way down to 1 is like, in other words, something that makes the national debt look like chump change. It's huge, huge. Like crazy, crazy big. Like Google big. Y'all know what Google is? What does Google mean? Google, the website. You know, it's actually a number. The person that designed Google had a math degree. They named it after a math number. Did you know that? You know, Google is a number. They actually spelled it different. It's like that. Google. But what is it? Nobody knows? It would be weird, really, to know. It means 1 with 100 zeros. That's what a Google is. It is a 1 with 100 zeros. In other words, it's gigantic. That's what the Google person was saying who started the website. It's going to be gigantic. It's going to go everywhere and search super fast. I remember when my kids were little, and I told them that fact. They were very nerdy, and they would like to say to their friends, like pridefully nerdy, and they would say, if their friend said, "Yeah, I just had a ton of ice cream," they would go, "Well, I had a Google of ice cream," and they would just think that's so cool that they knew that was a really big number, and their little friends didn't. Anyway, that was dumb. I'm glad they've outgrown that. But anyway, so don't be that way. Now that you know what it is, don't be weird with it. It just means 1 with 100 zeros. Anyway, so this number is gigantic like that. I mean, not quite that big, but really, really, really crazy big. So really, your calculator isn't going to be able to answer it. You could try. I don't think your calculator can even handle it. Does it give you error? 25 factorial error, or just like E with a number and like tons of spots? Anyway, it's going to be crazy big. Calculator can't even do it. So we need to do it by logic. How do we know if 80 goes into 25 factorial? How do you know if one number, this goes to the theory, how do we know if one number goes into another number? How do we know if this goes into that or anything into anything else? If all his stuff is in there, right? Let me get a fresh screen and do it. So what they're forcing you to do in this section is understand the theory of divisibility. That's where we're trying to go deeper. And so notice your calculator is not going to be able to answer this or most of these, maybe that first one, part A, but not the rest. So you're going to have to be able to think out what it means. So what I mean is you have to look into what's in an 80. What's in 80? 8 times 10. What's in 8? 2 times 4, 2 times 2. Remember, it's all about primes, huh? Remember how we've learned that with number theory? It's all about primes. If you find out what's going on with primes, you really know the story. So what's in an 80? 4 2s and a 5. That's the guts of an 80. 4 2s and a 5. That's an 80. That's the DNA stamp of an 80, so to speak, right? That's the signature of an 80. So Does that go into 25 factorial, which of course means 25 times 24 times 23 times 22 times 20, on down you go. Do you think all of this stuff is found somewhere in all of that stuff? Oh, for sure. Right? In other words, can I find 4 2s and a 5 among all this stuff? Well, right away, 25 has 2 5s in it already. Right? That's his DNA stamp. And come on down to 20. There's another 5. 4 times 5. There's another 5. I've already got 3. Oh, I only needed 1 5. What am I doing? I already got plenty of 5s. I don't need any more 5s. Anyway, I need some 2s, though. So 24. That's already got how many 2s in it? How many 2s in the 24? No, we're talking about multiplied together. So if we broke this down, 4 times 6, 2 times 2, 2 times 3. How many 2s in the 24? 3 2s. So you know what I mean? So I'm talking about how many, the DNA stamp of a 24. It's 2 times 2 times 2 times 3. So he's got 3 2s already. We only need 4. We only need 1 more. Here's 1. 2 times 11. He's got a 2. And we got zillions more. Not zillions, but lots more. So yeah, so the answer is true for sure. Because, so do you see what I mean? Divisibility means, does all this stuff fit into all that stuff? That's the basic meaning of divisibility. Well, so you just break down the left side, 4 2s and a 5, and you ask yourself, are there 4 2s and a 5 on the other side? Yeah. So then it goes in for sure. Can you try that same thing on part C? Does 15 divide into 10 factorial? So I'll give you a second. So what do we think?
True.
And how do we know it's true?
Because
What's in it?
15 has 3 and 5. And
15.
When you do 10, you get the 5. And then when you do 9, you get the 3.
Bingo. Yeah, so 15 is made out of 3 and 5. That's his DNA stamp. That's what's in a 15. 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And so if we break down all those little pieces, 2 times 5, 3 times 3, already we've got plenty of 3s, plenty of 5s, and I just got started. For sure, we have a 3 and a 5. You see, that is a 15, huh? If a 3 and a 5 get together, they make 15. They are 15, aren't they? Does that make sense? To see in a little deeper into the structure of numbers? So that one's for sure true. How about D? Is D true? Want to try that one? In fact, why don't you do D and E? Yeah, so let me give you a second. Stated, I think, quite well. So let's jump down to E. E's the trickier one. Is 2 to the 60th divided into 100? Notice that factorial there, right? So it's 100 all the way down. Yeah, so the question is, so 100 times 99 times 98 times 97, all the way down to 1. So the question is, are there 62s? That one's already broken down. Huh? We don't need to do any of that one. That one, there is his DNA stamp, right? 62s. Are there 62s among all this stuff? Are there? And Bridget, right, Bridget? Yeah. Was saying, well, we have 100 numbers here. Every other number's even. Like 100, 98, 96, right? So half the numbers are even. 50 of the numbers are divisible by 2. Would have a 2 in them, wouldn't it? So there's 52s right off the bat without even trying hard. There's 52s. Now we just need 10 more. Do you think we can drum up 10 more? Yeah, because lots of numbers have more than 1 2. You know, every other number has 1 2 at least, and a lot of them have a bunch more, like 100 itself. That's 10 times 10, 2 5, 2 5. So he has 2 2s. He's got an extra 2. Then there's numbers like 16, which actually have how many 2s? 4 2s. So there's 3 more. Yeah, we'll easily come up with those other 10 2s we need. That one's true. Does that make sense? Bridget's reasoning is solid. There's got to be, I don't know how many there are, but there's plenty. There's plenty of 2s. How about D? What was the answer to D? That one true. So that one, I haven't worked it out. Is it not bad? What is 48? 6 times 8. And then, yeah, just keep breaking it. Get some room here. Just keep breaking that down. So 2 times 3, 2 times 4, and then 4 is 2 times 2. So we got, what's that? 5 2s and a 3. So there's his DNA stamp. 5 2s and a 3. Does that go into 6 factorial? 6, 5, 4, 3, 2, 1. Are there 5 2s over there?
Isn't it 4 2s?
Oh, did I mess up? Oh, you're right. 4 2s. That's important, huh? That would change the answer, wouldn't it? Yeah, 1, 2, 3, 4. Yeah, I messed up. Don't mess up. I was just trying to show you how easy it is to mess up. 4 2s and a 3. Are there 4 2s in 6 factorial?
Yes.
Yeah, because there's a 2. 4 has 2 2s, and there's another 2. There's 4 2s. And is there a 3? Yeah, right there. And there's 1 in the 6. We have plenty of 3s. So, yeah, it goes in. That one's also true. Good? Is that making sense on those? Questions, comments? Try that one out. So try it out at your own tables. Try F. Think about it. Questions clear. They're saying, does 30 divide into, this is the divide into thing, 30 factorial add 1? In other words, does 30 divide into 30 times 29 times 28, all the way down to, times 2 times 1, and then add 1 at the end, whatever that is. So this whole 30 factorial thing, some gigantic number, way too big to get even on our calculator, and then add 1. So whatever you get after you add 1, will 30 divide into that whole thing? That's the question. Let me help. Let me ask this. Would 30 go into 30 factorial? A lot of times, one of the strategies, this is actually a good point for me to give you a strategy. One of the things, and I really hope you will teach kids problem-solving techniques. Like, just how do you attack a problem? Really, a lot of those little people are going to bubble up and become scientists and engineers and things like that. And really everybody has to be a problem solver at some level. Some people are paid to be problem solvers. Some people just do it more casually. But everybody solves problems to some levels. How do you become a good problem solver? Well, there's a lot of techniques. One of them is make the question simpler. That's one good strategy. Especially if you're looking at a really hard, confusing question. One of the main things that I try to do, and not just me, it's what everybody does who's spent some time problem solving, is they make the question simpler. So get rid of that one. Just answer a simpler question first. Would 30 go into 30 factorial?
Yes.
You seem very confident about that. How do you know for sure? That's in there. I mean, it's just like, 30 factorial. That's 30 times 29. So everything in a 30 is in that 30. So yeah, of course. So that would be a yes. That would for sure be a yes. Now, what happens when you add 1? What happens, let me make the question more general. What happens when you have something, I don't know, anything, let's just say, whatever, 7, and it goes into something like 21, right? I'm just going to pick an example. So again, I'm going to ask myself a question similar. Notice the specifics of this yes, no answer, who cares? What's more important is how you attack a question you don't know the answer to. I start with a simpler question, and then I start reasoning about things like that question. And I say, okay, I got one thing going into another with a yes. And then I'm wondering about adding 1. Will the add 1 wreck it? Or will it be okay? Well, I don't know. Let me try some numbers I know. Here we go. 7, there's something that goes into something, right? 7 goes into 21, perfectly, evenly, no remainder at all. 3 times, beautifully, no remainder at all. So what if I add 1? Will that wreck it?
Yes.
It sure will. What'll happen? If I try to go in, I'll have a remainder of 1. Of course. Because it went perfectly into that. So if you add 1, it'll go perfectly with the remainder 1. So it won't go perfectly, in other words. Does that make sense? So if you go into something cleanly, and then you add 1 to it, that's the remainder, isn't it? Like if let's pick another one. How about 9 goes into 18? Perfectly, cleanly, right? 2 times. Whoop, 18. No remainder. So then if I add 1 to it, 19, then it'll go in the same amount of times, but now not cleanly. Now that 1's the remainder. So what do we think is the answer to this question?
False.
Yeah, it's got to be false, doesn't it? Because we know it goes into this piece. So therefore, if you add 1, it's going to have a remainder of 1, won't it? That makes sense? All right. I'll move on if you're good with that. How about number 2? Can you talk about number 2 there? Find the largest in. We want to find the biggest power we can put on that 2, meaning how many 2's can go into 14 factorial. 14 factorial. So take that 14 factorial, write it out, and see how many 2's are in there. That's basically what you got to do, right? Yeah, so basically when you're saying 2 to the n, so 14 factorial, that's going to be 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So if I break down all those numbers, like 14 is 2 times 7, so there's a 2. 12 is 4 times 3, which is 2 2's, huh? And then 10 is 2 times 5, so there's another 2. 8 is 2 times 4, so that's got 3 2's in it. 6 is 2 times 3. 4 is 2 times 2, and then there's the 2 right on the list. Right, so just count them out. Be careful, it's easy to miscount. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 11. So notice 11 is the biggest power you could put there and have it go in, huh? If you tried to make it 12, 2 to the 12th would not go in because there's not 12 2's over there. Getting the idea of divisibility? If it's that in there, it goes in if it's in there. So the biggest power, the largest in, is 11, isn't it? Biggest power. Want to try B? That one's a little more tricky. We're looking at 6 now. The trick is 6 is not a prime. It can be broken down, huh? 6 is made out of what? What's his DNA stamp? 2 times 3. So they're really asking 2 times 3 to what power goes into 20 factorial. So try that one. All right, so let's go to a fresh screen here. So, so 6 to the n, 6 to some power going into 20 factorial. So what's in a 6 is 2 times 3. That's the DNA stamp of a 6. So we want 2 times 3 to some power to go into 20. We want to know how many times it'll go into 20 factorial. So, bless you. So 20 factorial, let me write that out. 20 times 19 times 18, 17, 16. Well, how about, you guys have done the hard work. There's a bunch of 2's. How many 2's? All right, we'll say a lot of 2's. A lot of 2's and 8 3's, y'all said, right? Eventually we arrived at that conclusion. There's a lot of 2's and there's 8 3's. So when I say a lot, there's more than 8, like, I don't know, 15 or 20 or something, 2's, right? So, question, I don't know if it's 15, but whatever. There's a bunch of 2's and there's 8 3's. So what does that mean about how many 6's are in there? Yeah, so you guys are saying that it's the lower number, it's the number of 3's, not the number of 2's. Yeah. Well, 2 times 2 is 4 times 2 is 8, huh? Because we're not adding. It's easy to switch up adding and multiplying. Yeah, since we're multiplying, they won't. Yeah, good question. So why is it that we use, you guys are saying the answer is 8. Why is it we use what there's less of and not what there's more of?
Because to make a 6, you need a 2 and a 3.
Because to make a 6, you need a 2 and a 3? And so?
They're wrong.
No, you guys are right. You know, how would you explain that? I don't know why, but to my knowledge, it's like a junior high dance. Remember junior high dance, right? The boys and the girls for the first time. Maybe they start younger now, I guess. But anyway, whatever. Junior high dance. What if you got way less boys than girls? Let's say you got 10 boys, you got 20 girls. How many couples are going to dance? Whatever there's less of, right? You're limited by what there's less of for the couples dancing. So that's exactly what we're doing with 6. A 2 and a 3 need to get together to make a 6. And so if there's less 3's than there are 2's, the lower number is going to control the number that get together. Yeah, you guys are right. 8 of them, huh? It's whatever there's less. So we don't even need to count the 2's. We know there's less 3's, just count the 3's. That make sense? I'm going to skip number 3. It's on YouTube. Let's try to talk them out carefully. So, all right, so basically it's a whole bunch of true-false questions. And, and with just letters everywhere. So it basically says if A divides B and A divides C, then A divides B plus C. Is that true or is that false? Well, I'm explaining up here that, What am I? Yeah, try plugging in numbers for A, B, and C, and then check to see if it is true or false. Yeah, that's the best way. Just make up some numbers. So I'm just going to say, all right, how about if A is 2, I'll say A is 2, B is 4, A, I've already said is 2, and C is, I don't know, 3. There we go. What's that?
Well, 2 wouldn't divide into 3.
Yeah, 2 and 5.
So it'd have to be like 6.
Oh, yeah. So then it's false, right? 2 doesn't divide. Yeah, do you see the point?
I meant your C can't equal 3.
Your C
because
can't equal 3.
It wouldn't divide. The 2 wouldn't divide into 3.
So the C can't, you guys are saying the C can't be 3, because it does, like, I'm trying to just make up numbers. You're saying C can't be 3. So does that mean it's false?
No, because that just means because you're taking a part that's already stated as being true and making it false. So then that's not actually the problem that it's asking you.
Exactly. Is everybody tracking with Cameron, right? With Cameron on that one? Does that make sense? That's what y'all are saying over here. That's right, huh? That'd be like if I said, remember how if-then logic works. Remember if it's a dog, it's what I always do, huh? Then it's a poodle. Right? I looked out the window. If it's a dog, then it's a poodle. Now that's not true. That's not true, is it? How would you prove me wrong, though? How would you show that I'm wrong when I said, if it's a dog, then it's a poodle? Would you look out the window and go, look, Mr. Heron, there's a cat out there, and that's not a poodle, so you're wrong. Well, I'm wrong, but that doesn't prove me wrong, right? You'd have to find a dog. You see, when somebody makes an if-then statement, you got to meet their if. You'd have to find a dog that's not a poodle, right? Find a German Shepherd or some other dog. Right? To say, look, Mr. Heron, there's a dog, like a German Shepherd, and that's not a poodle, so you're wrong. And I would be proven wrong. Right? So for an if-then statement to be broken, you've got to meet their if and break the then. You can't deny their if, right? If I said, if it's a dog, then it's a poodle, and somebody said, well, look at that cat. That's not a poodle. We'd all go, I didn't say cats were poodles. I said dogs were poodles. Right? Or all dogs were poodles, and that's wrong. All right, good. So you're thinking right. So first off, when I grab these numbers, you guys are right on the money. I can't pick 3 for C because I'm not meeting their if. They said if you got an A, B, and C where A does go into B and B does go into C. Or, I mean, A goes into C. So, yeah, I got to pick something else like 8 or whatever. Something else that goes in, huh? You've got to meet their if. That's what it means. When they say if, they're saying if this is true. So you've got to meet them there and then see if the then follows, right? So good job. So if A goes into B and A goes, I picked an A, 2. I picked a B and a C that meets the if. So does the then follow? At least in this case. Does A, what was A, 2, go into B plus C? What was B and C? 4 and 8. 4 plus 8. Does it go into 12?
Yeah.
It does. So does that mean it's always true? Probably, but that doesn't for sure mean it's always true, right? Just, like we know, like if you looked out the window and you saw a dog that was a poodle, if I said, see, I'm right, it's always true, all dogs are poodles. You'd go, well, Mr. Heron, just because that one dog's a poodle doesn't mean all dogs are poodles, right? So it's true. The trick with an if-then statement is just because you find one case where it's true doesn't mean it's always true, but it probably is, at least in these letter ones. It probably is. So you could spend forever trying to guess around in numbers to break it, or you could start to think, it's probably true. This one is true. Now, how do you actually show it's really true? Like there's no numbers that could ever break it. Well, that's higher level math. That's called number theory, and that's what you do if you become a math major. You learn to prove things like that. We aren't going there. So we're just going to say, yeah, it looks true to me. It is true. That one is true. If A goes into B and A goes into C, then it goes into B plus C. So what I would suggest then on an exam is try one group of numbers. If it comes out true, answer true. And go on with the rest of your test. If you have time at the end, come back and try a little harder to break the ones that came out true to see if there might be some other numbers that make them false. If you ever get false, you're sure it's false right away. Let's try the next one. If A divides B plus C, then A divides B or A divides C. Let me let you try that. So I'm going to wrap this up. I want to get to C with you real quick. So yeah, so like I heard a good example up here, Diana, right? Yeah. Diana. In the front, she said if 2 goes into 3 plus 3. By the way, you can let B and C be the same number. They can be any number. If that bugs you, you could do 3 and 5, huh? 2 does not go into 3. And 2 does not go into 3. Now, if you're bugged by the 3 and 3, then just do 3 and 5. It's still not going to work, right? Because 2 does go into 8, but it doesn't go into 3 or 5. So that is a false statement. And we're sure when we get false. No way is that true for all letters, because we found some specific letters it's not true for. That makes sense? A does go into them added. 8, right? 2 does go into 8 evenly. But it doesn't go into 3 evenly, and it doesn't go into 5 evenly. It has remainders for both those. See why that's false? They said if you go into 2 numbers added evenly, then you will go into the first one or the second one evenly, and that's false. Try number 3. We'll wrap up with number 3. When they put the not, right, that means not. So if A does not go into B. If A does not go into B. So let me, we're running out of time, so let me just pick one. What do they mean A does not go into B? I've got to pick a number like 2 does not go into 3. I got to pick something that does not go in. And A does not go into C, like A does not go into 5. Then A will not go into 3 plus 5. Oh, but it does. That's false. See how I know the nots confuse people out, so I want to show you one of the not ones. All right, I'm going to have to leave the rest to you.